So guys, let's try to find a pattern in a string in a different way, right? We'll be using the LPS array, but we'll see a very beautiful way, very interesting way to find a pattern in a string, right? So let's say I have a pattern AB A, right? And its text is like A B A B A E. Here pattern in text का मतलब क्या है? Pattern should actually exist in a substring, right? So it is also a substring finding algorithm, right? So guys, basically if I write it like this, कि if I make a new string, right? Let's make a new string and let's name it pattern plus some random character that is not in the text, not in the string, plus text, right? Basically I made a gap between these two, pattern and a text, right? So what will be then my new string? It will be ABA dollar ABA, right? Now guys, if I try to find the length of the longest prefix which was also a suffix at a particular position, then काम बन जाएगा ना मेरा, right? For all those indexes where I have got a length of the longest prefix which is also a suffix and it is of length 3, तो उसका मतलब क्या है? These 3 characters match with these 3 characters, right? The length of the longest prefix which is also a suffix, right? So if these 3 and these 3 matched, so what does that mean, guys? If these 3 and these 3 match, that I have found a occurrence at that position, right? I hope you're understanding me. It's a like it's a very good way to understand for some string algorithms. There are various questions that can be solved by just applying a string concatenation with a dollar sign or a and sign, right? So why have I applied a dollar sign, guys? Because we can never find a string of length 4 which will also be a suffix of length 4, because after this there is no dollar, right? And never 5 and never 6, because there is only $1 in the whole string. I hope you got it, right? So let's try to code it. So I have a text and a pattern, and I will be only using one this function that will be compute LPS better, right? So let's make a new string good equals to how much? Pattern first plus ampersand or dollar whatever plus text, right? So I've concatenated this good string, right? Let's just print this good, right? So this is the string. Now what I'll do is I'll just make a function called calculate LPS better, right? So this was the function calculate LPS better. Now let's try to print all the values, right? And also copy it from the above only. Most of you must have understood it. Okay, it is not as, it is good. It's not as, it is good. See, right? Did we get 4? Why we didn't get 4? Because this character, it never matched. So we got an index 3 here and then 3 here. That means the length of the longest suffix, which is also a prefix. And what is the prefix? Prefix is a pattern string, right? So again this algorithm will take O of n steps only and one function call, right? So okay, let me just save it in the occurrences also, so that you all don't get confused. Vector int occurrences, and in this occurrences what I'll do is I'll just iterate over all the LPS values. Let me just erase this. Iterating over all the LPS values. If LPS or x, right? Okay, I need the ith index also, so I have to start from I equals to 0, I less than good dot size I plus plus, right? So basically if LPS I equals to how much? If LPS at that position equals to uh, pattern dot size, right? So LPSI equals to pattern dot size, and of course I should be greater than the pattern size, right? So let's start from pattern size itself. Pattern dot size plus 1. Why am I not starting from 0th index, guys? Because you can see ना कि यार एंड बाद में लगाया मैंने. It can be triple A, right? तो वो तो पूरा मैच कर ही देगा, right? Or won't it match? It won't match because it can never be equal, right? LPS value is always less than that value, right? But this is also good. Why am I starting from pattern dot size plus 1, right? I'm starting from this index, from where actually the text begins, right? I'm actually starting from that position, from where the text actually begins. So if LPSI equals to pattern dot size, so simply occurrences dot pb, that is push back how much? I minus pattern dot size plus 1, right? I minus pattern dot size plus 1. By plus 1, I minus 3 plus 1 will give me the starting index, right? So let's print now occurrences. You can do this yourself also, right? It wasn't that tough. Right? So acha, so so here's a one more issue over here. We got an index 4. So this index 4 is according to the string good, right? In which I had both pattern and text, right? So to reduce it further, what can I do? To reduce it further, what I can do? I can just subtract from this index. I can just subtract how much? Pattern dot size minus 5, or like subtract from this pattern dot size means actually to 4 I have to give index 0, right? So it will be plus 1 then, right? Why am I doing so? Why am I saying like subtract pattern dot size plus 1 from it? Because this 4 is according to the good array, not according to the text string. It is according to the good string, right? So that's why I need to reduce those indexes from where the text starts. It starts from how much? Pattern dot size plus 1. So I have to just reduce it further, right? So it is how much? 0, 3, 5, 7 and 10, 12, right? Same as we computed before. So I hope you got this new method of making string algorithms work easier. So just you need to just make a only one small function, that is compute LPS better. This very small function, I hope you actually have understood it, right? And you can also code it yourself now. It is not that tough anymore. Just code wherever you face this string matching things, just write this function, do pattern plus string, pattern plus text, and find the LPS value for that, right? So there can be various questions made. You can now go and try to practice all those questions, right? Okay, so guys, thank you. See you in the next video. The next video I'll be discussing the Z algorithm and the manager's algorithm also, right? So see you.